Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episode. This is the episode number 102. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal is bicyclic system which has 1,4-diene with conjugated ketone as well as 1 methyl in the cyclohexane. You are using the acid. They ask you to find the product. The product suggests that the methyl and OH position are different. Methyl groups are shifted to next position or the OH groups are shifted. So definitely rearrangement is occurred. The question is really about methyl and OH position. The answer is A. Let us see how. The starting middle you have ketone, you are adding acid there. So what really happens is oxygen will be protonated. Positive charge will be generated there. So the positive charge can travel to the system because the conjugated ion is there. So charge travels to the next double bond and further travels to the next double bond. You have the secondary cation there. So secondary cation will be there and there is a possibility of tertiary cation by methyl shift. That is called Wigner-Melvin rearrangement. The whole rearrangement dictated by cation stability. Tertiary cation is more stable than secondary. So by shifting the methyl group, you form the stable tertiary cation. That's why it's called Wigner-Melvin rearrangement. So you have the cation and charge has to be quenched. What is the driving force here? So aromaticity is the driving force here. So you got the answer A, aromatic system with alcohol and methyl which is shifted from the. Here you have to learn 2 important things. The cation stability. Whenever you form the cation travels to the double bond and it forms the stable cation. If still the stability is not established, methyl group shifted and you have Wigner-Melvin rearrangement. Second thing is Wigner-Melvin rearrangement. Wigner-Melvin rearrangement always promote the stable cation. The whole rearrangement dictated by cation stability. Then the question number 2. The starting middle is 5-member and 6-member ring where methyl and hydrogens are anti to each other. In the 5-member you have alkene and it is conjugated with ketone there. So side chain it contains ketone with methyl. You are using hydroxylamine hydrochloride and aromatic SO2Cl. Then you are using pyridine. You are heating and you are expecting the product there. They suggested 4 products. The first product is amide with N attachment. Second product is amide with CO attachment. The third product is the heterocyclic system with nitrogen and oxygen. The fourth product is the heterocyclic system with aromaticity. So there are the 4 possibilities. Here from the hydroxylamine you might guess naming reaction is involved and the ring forming possibility is the question here. The answer is A. Let us see how. The starting middle you have ketone, you are using hydroxylamine. So direct water elimination, hydroxylamine formation. You are using the aromatic sulfate. So what really doing is it's like tosylate. For convenience we write it as tosylate. Tosylate is a good leaving group. So once you heat it, the tosylate removes, you have the cation there. So the cation formation is occurred. The cation has to be quenched. How the cation has to be quenched? It is called Bachmann rearrangement. The Bachmann rearrangement, the hydroxylamine converted into N cation. The anti-group migrates, establish the stability. So what really happens is the anti-group is the ring there. So ring migrates to the 5. So new 1,5 bond formation there. 2,1 bond will be breaking there. So you have the new CN bond formation. You have again the cation. How the cation will be there? You are using the water. Water attack the OH. You have OH formation. Then the next step, the OH and alkene. You might think of ketoenol tautomerism. You have N attached amide. So which is A. Here you have to learn 2 important things. One is hydroxylamine. The hydroxylamine, the OH is the poor leaving group. We make it as good leaving by TS formation, the tosylate formation. Second thing is Bachmann rearrangement. Bachmann rearrangement always anti-group migrates. You have the amide there. Then the question number 3. The starting metal you have cyclopentane which attach with hydrogen tosylate, and you are having methyl. Both are in 1,2 position. Then you are using butyl lithium along with DMF, dimethyl formamide. They ask you to find the product. The product can be 5-member aldehyde or dimethyl aldehyde or the conjugated aldehyde or aldehyde in the 1,3 position. So from the reactant hydrogen you might think of naming reaction, and there is a aldehyde attachment. So there are the two naming reaction is involved here. The answer is C. Let us see how. The starting metal you have the hydrogen and you have active hydrogen there. You are using butyl lithium. Butyl lithium abstract the proton because it's a strong base, so the anion is formed. The anion has to be quenched. So the hydrogen anion quenching process is Sapphire elimination. You have alkene at the end. So N minus is there. The nitrogen in the lone pair donates the electron. You have N and double bond. TS is leaving. So TS elimination. Next step you have N plus and N minus, which is a triple bonded character 1. So nitrogen is a good leaving group. So nitrogen leaves. You have alkene anion formation. The anion is there. You are reacting with DMF. This reaction is called Boelt aldehyde synthesis. This synthesis is the direct attachment of aldehyde, where amine leaves direct aldehyde formation. So the answer is clearly C there. Here you have to learn two important things, which is naming reaction. One is Sapphire elimination. Sapphire elimination is hydrogen converted into alkene through the butyl lithium proton abstraction. Second thing is Boelt aldehyde synthesis. Boelt aldehyde synthesis reacting DMF with anion, you got the aldehyde, which is direct attachment to the system. Then the question number 4. The starting metal is 6-member ring with containing sulfur heteroatom and it attached with oxide. You are reacting with acetic anhydride and sodium acetate. They are asking you to find the product. The product can be cyclopentane with alkene, or the same heterosystem with ACO attachment, or the ketone attachment, or the cyclic 3-member sulfoxide formation. 4 possibilities. So from the reactant you might guess the sulfoxide. So naming reaction is involved and selectivity of AC attachment is important here. The answer is B. Let us see how. The starting metal you have sulfoxide. So we redirect to the charges. We write it like E like there, where O minus and S plus. The negative charge formed at more electronegative atom. So O minus is there. So O minus here is a nucleophile. It's a surprising finding. The O minus attack the acidic anhydride. So what really happens is CH3COO eliminates. You have new OC bond formation. So new OC bond is formed. If you look at the system clearly, again a 1 acetate formation. So CH3COO minus again have the possibility of elimination. So CH3COO minus eliminates by the hydrogen donation. The hydrogen leaves and it helps to remove the acetate there. So you have sulfur cation. So the double bond is there. Again the charges are stabilized. The cation at the second position. The removed acetate attacked again. You have acetate in the second position. So clearly the answer is B. So what is important here? It's a boomerang rearrangement, because the CH3COO is attached on one position, it converted into second position, and very importantly oxygen is a nucleophile in the first step. Here you have to learn two important things. One is boomerang rearrangement. It is switching of acetate group from O to the second carbon. Second thing is you have to know the acetate is a stabilized system. It can be removed easily. So it's a very good leaving group. Then the question number 5. The starting metal is linear system which have alkene and ethyl, and you have the ester kind of architecture. It has two carbonyl ions nearby, many functional groups here. Ketone, ethyl, alkene and alkane. So you are heating and removing the CO2. So one carbon is removed from the system. They ask you to find the product. The product can be of any type, only the position of double bond is the real question here. The double bond position and ET position is the real question here. Where is the ET there? Whether the ET on N or ET are middle to the ketone. There are the possibilities. Definitely the rearrangement is occur because you have suppling of carbonyl group and the CO2 elimination. So you have to guess definitely carbon skeleton changes occurred and rearrangement definitely occurred there. The answer is B. Let us see how. The starting metal you have two carbonyl group within the middle methylene group. It is an active methylene group. So there is a easy formation of enolate or hetoenol tautomerism. So enol forms there. So O become OH. You have two dienes there with middle oxygen. So you might think of 3,3 sigmatropic rearrangement. So we redraw the structure to the cyclohexyl form with side chains. So if we redraw nicely, the oxygen will be on 5th. The dienes are in the 2 and 6th position. So you might think of 3,3 sigmatropic rearrangement. So the bonds are shifted. You have new 3,3 sigmatropic rearrangement. So you have the acid formation because of the bond switching. So you have acid, you are heating, acid will be removed as CO2. The CO2 6,5 bond is removed and you have hydrogen there. So if you redraw nicely, you have the answer B. Here you have to learn two important things. One is the active methylene group. The active methylene group always promote the enolate formation by hydrogen removal. Second thing is you have to imagine the molecule for the rearrangement. If you have terminal alkene, you have to think of the rearrangement there, which is normally 3,3 sigmatropic rearrangement through 6-member ring formation. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.